Okay, good morning, guys. Um, this time around, we are moving to indices, like index notation, and and we have some laws that guides indices before you'll be able to solve indices. Though it's also one of the part in mathematics that's also simple. Okay, so but we'll be taking it one after the other. So this time around, this is indices part one. Okay, so but what do we understand? So this part is very very important in mathematics. Okay, so you can't escape it either in exams or in post UME or in UME. So it's very key. So even in school in part one, we still learn them. So now, indices. What does it mean when you see indices? How do you identify that? Okay, so I just portray this with an example. Okay, we have an example here that we have, you have 5 times 5 times 5. Okay, maybe you see that somewhere. Okay, maybe in an exam. Okay, what do you need to do? So what's the meaning of indices? I'm using it to define indices. When you have common numbers, which is 5, you have 5 here, you have 5 here, you have 5 here. Okay, I've told you that if we write any figure in some of the part I've mentioned, if you write any figure, maybe like let's say 2, if you're standing, that 2 is raised to power 1, because anything raised to power 1 is still that thing. I think I remember I said that joy raised to power 1 is what? Is joy. So in this case now, you have 5, 5, 5. So it means they have a common base, okay, which is you take 1, 5, then you take the power. The power is 1 plus 1 plus 1. That is 5 raised to power 3. It means that you are writing 5 3 times. Instead of me writing 5 3 times, I can also write 5 raised to power 3. So in this case here now, so it means that this 5 is what we call the base. Okay, why 3? I know I've mentioned this before because I understand that I think I mentioned it in one of my parts, either in SOL or in the other topic that I've also mentioned, which is factorization, that anything at the top here, at the top here, you call them power or index. Okay, and that is why the topic is called indices. So the habit or the method of shortening figures like this, okay, shortening figure like 5 to represent 1 5 and power 3 is called index notation or indices. You understand? So the same thing applies here, which is we don't need too much story because in mathematics, you don't need to, it won't be asking you the definition of this, the definition of that. All you just need to understand is what does it mean? How can I practicalize this? How can I apply this particular topic in any of the exam given to you or in any of the exam given to you under this topic? So look at example number 2 now. Example number 2 is B times B times B times B. It can be any alphabet. I've told you in mathematics we play around with many alphabet as possible from A to Z. Okay, but in this case now I'm just using B to represent this. So this is B times B times B times B. So what do I do? They have a common base. What is the common base? The common base here is what? Is B, and then the power here is 1 1 1 1. So it means that I'm writing B in 4 places, which is B raised to power 4. B is the base, okay, 4 is the power or the index. So which means that the method of shortening this particular B that I've written 4 times, the method of shortening it and representing it with power is what we call index notation. So that is very simple. It's very, very straightforward. So to the major part of indices, we have laws of indices, like the way we have laws in sort. Like I mentioned multiplication law in sort. I also mentioned division law in sort. Okay. We also have laws of indices, so that when you see a particular question or a particular question under this particular topic, you'll be able to know that, oh, this is multiplication law, oh, this is one is division law, oh, this one is power law, this one is, you'll be able to identify them. So I've taken my time to be able to simplify this. We have what we call multiplication law. Multiplication law has two conditions. The first condition is that they must have equal base. I've mentioned it, 555 equal base, B is equal base. Okay, then what do? You add the powers. Okay, which is what we've done here in part of the example that we're giving to, but it's part of the law. We've had the power here, 1 1 1, which is 1 plus 1 plus 1 plus 1, that is 3. So the same thing applies here. For multiplication law, they must have equal base, okay? And also you must add the powers. So in an example, I've represented it with an example here. If you have 2 raised to power 3, 2 raised to power 4 times 2 raised to power 1, I can decide not to write this 1 here. Don't forget, anything, if I write any figure, is raised to power 1, because joy raised to power 1 is still joy, okay? So if I say 7 raised to power 1 is still 7, okay? B raised to power 1 is still B. Ordinary B, I wrote ordinary B is also raised to power 1 because it's still the same thing as B, okay? So in this case now, I just put this 1. I can decide not to put this 1. It's still the same thing. So 2 raised to power 3 times 2 raised to power 4 times 2 raised to power 1. Indices, what do? Pick the common base. That's the definition of indices. What's the common base? The common base is what? 2. What do? The second condition, add the power. So the power is 3 here plus 4 plus 1, which is equals to 2 raised to power 8. It's as simple as that. The same thing applies here. In indices, you can also play around with alphabets, okay? Like I've mentioned when I was introducing the topic. So look at this now. This is A times a raised to power 5 times a raised to power 2. This a raised to power 5 is the same thing as writing a in 5 places. This 2 raised to power 3 in example number 1 is the same thing as writing 2 into 3 places. This 2 raised to power 4 is the same thing as writing 2 into 4 places. But indices has made it easy for us that we can shorten it. You don't need to write them in 5 places, okay? Which is the same thing as a raised to power 5 times a raised to power 2. Pick one base. What is the base here? The base here is what? A. Then you add the what? Power. That is equals to a raised to power 5 plus 2, which is a raised to power 7. It's as simple as that. As simple as this thing is, you can see it in objective part, okay? So immediately you see it, just don't waste your time. They can just tell you simplify a times a raised to power 5 times a raised to power 2 times a raised to power. But all you just need to do, just add the power. Pick one base and add the power. So the same thing applies here. I give this example just for you to know. 3 raised to power 0, I've told you in one of the part that we've done, either in factorization or in sort, all the part that we've done so far, I've mentioned this. Anything raised to power 0 is equals to 1. We all know that in mathematics, okay? If you don't know it, better know it now. Okay, 3 raised to power 0 is the same thing as 1. But instead of me writing 1, I can as well write 3 raised to power 0. Joy raised to power 0 is what? 1. Okay, B raised to power 0 is 1. A raised to power 0 is 1. K raised to power 0 is 1. Anything raised to power 0, in fact, is 1. Okay, a television raised to power 0 is also equals to 1 in mathematics. So I intentionally put this here so that when you see it somewhere, you should know the interpretation of what exactly they are saying. So 3 raised to power 0 times 3 raised to power 3 times 4 raised to power 4 times 4 raised to power 5. So this is a combination of two different bases. Okay, I intentionally put this there so that I can explain it to you. If you look at here now, what is the base here? The base here is 3. The base here is 3. The base here is 4. The base here is 4. The question I need to ask myself, that is base 3 the same thing as base 4? No, they are not the same thing. All you just need to do, pick the one that has common base, okay, and have the power. That is the condition for multiplication law. Pick the one that has common base and have the power. What did I do here? Look at 3 here. Look at 3 here. They have common base. I pick 1, 3. What did I do? I had the power, which is 0 plus 3. Okay, so the same thing applies here. 4 here, you have 4 is common here, 4 is common here. You pick 1, 4. You had 4 plus 5 equals what? That is, I pick 1, 4, then I had the power, which is 4 plus 5. So the answer to this is now was 3. 3 plus 0 will give me 3. That's 3 raised to power 3 plus times 4. That is 5 plus 4 is equals to what? 9. And I've gone ahead to be able to explain, to give you an example that you can play around with, or we can also mention it here. That was why I left that small space. You can simplify 7 raised to power 2 times 3 raised to power 1 times 7 raised to power 3 times 3 raised to power 5. This is very, very simple. All you just need to do is just to pick the one that has common base, which is 7 and 7. Okay, that's the same base. Now look at this one too. They have common base, which is what? 3 and 3. Okay, all I just need to do is just to come here. I can just say this number one is just you have, that's number one here. You can have, that's I pick 7. I can rearrange it and say 7 raised to power 2. Okay, then times I think my marker is going out. Then you have 7 raised to power 3. Okay, then you now have, if you look at what we have here in number one here, 7 raised to power 2, 7 raised to power 3. I have to rewrite them, which is 7 raised to power 2 times 7 raised to power 3. Then you have 3 raised to power 1 times 3 raised to power 5. So the 7, which is the common base, you pick 1 7. Okay, you pick 1 7, which is the common base. What do? You add the power. So the power is 2 plus 3. Okay, so the same thing apply that you can do for the other one. You pick one base, which is what? 3. Okay, so you have, that is 1 plus 5. Okay, so I think I'll have to get another marker here. So you have 1 plus what? 5. So that is it. So it means that here at the end of the day, I can have 7 raised to power 5 times 3 raised to power 6. So that's a simple. So that's just for the first question that you have here, which is 7 raised to power 2 times 3 raised to power 1 times 7 raised to power 3 times 3 raised to power 5. Okay, so you can try this. This is very simple, of which I can also bring it out. So this one is a raised to power 8 times a raised to power 2 times 2 raised to power 5 times 2 raised to power 7 times a raised to power 1. It's very simple. All you just need to do is just to bring all the common base together. Bring all the common base together. The common base, a raised to power 8, a raised to power 2, and a raised to power 1. Pick one base and have the power. The same thing applies here. C raised to power 5, C raised to power 7. Pick one base, which is C, then add the power, which is 5 plus 7. Okay, so now in this case, now after treating the multiplication law, there's what we also call division law. Division law is very straightforward. The same thing applies here. You have equal base, and you do what? You subtract the power. So the only thing that is different from multiplication law and division law, for multiplication law, you had the power. But for division law, you subtract the power. And I've given an example here. For 5 raised to power 6 divided by 5 raised to power 2, pick one base. Okay? You pick one base. What is the one base that is here? Which is what? 5. So it means the answer here is the same thing as writing 5 raised to power 6 minus what? 2. Okay, so it means that I pick one base, which is what? 5. So, and I subtract the power. Second condition, 6 minus 2. Okay, so if I subtract 6 minus 2 here, that will give me 5 raised to power 4. So that's the same thing. So don't forget that, like I said, this is the same thing as writing 5 in 6 places. 5 in 2 places. You can now cancel 5, 5. So it will remain 4. So instead of you going through that rigorous process, indices has given you a method of shortening it, which is the definition of index notation. Okay, so just short it and subtract the power and reduce your stress. Okay, that's the same thing applies here. I might not write the division as this. I might write it as a long division like this. So it's still the same thing. This one is the same thing as what? D raised to power 10, D raised to power 5. Common base. They are common. So all some of these things has law. Because it's common, pick one D. So this one is the same thing as saying D raised to power 10 minus what? 5, which is the same thing as what? D raised to power 5. It's as simple as that, just like chin and pure water. The same thing applies here. M raised to power 7, M raised to power 3. I can play with any alphabet in mathematics. So this one is also the same thing as saying m raised to power 7 minus what? 3, which is m raised to power 4. So it's as simple as that. It's as simple as that. So you don't need to. So that's what we call division law. Just note, multiplication law, equal basis, add the power. Division law, equal basis, subtract the power. Those are the things you just need to note. So I just give this one as an example that you can play around with. Okay, we have b raised to power 5 divided by b raised to power 0. And I've done something related to 0 here. This one is same thing as k raised to power m divided by k raised to power n. So in our next class, we'll continue with laws of indices. Okay, then we can just give more than enough example. We have a lot of, a lot of questions on under this part, so it's very key for you to understand them. That is why I'm not ready to rush. I'm not rushing them. Okay, so I'm taking one after the other so that we can get the best out of this topic. Okay, so please continue to like, continue to share, and continue to comment, because as we continue to share, we continue to reach a lot of young minds, or a lot of students that are having challenges with mathematics, so that at the end of the day we can cop the gap, the gap of young minds having, having this mindset of mathematics is difficult, mathematics is not I can't solve mathematics, of which mathematics is very simple if you can understand, the basics, and then some laws guiding each of them. Then at the end of the day, you'll be able to, out of 50 questions, you'll be able to solve like 45 questions, and then you'll be okay for your exam. So it's very simple. Please continue to like, comment, and share. Cheers. Thank you very much.